In this video, we're going to focus on states of matter, at least the most common ones that you typically encounter. And so these include solids, liquids, and gases. But first, what is matter? Matter, you could think of it as stuff. It's basically anything that has mass and takes up space. Matter is composed of individual tiny particles known as atoms, and matter can be classified into one of these three different categories. Now let's talk about solids. A solid has a definite shape. So if you think of a rock has a fixed shape. I know this is a terrible visual illustration of a rock. It has a fixed shape and a fixed volume. Liquids, on the other hand, they're fluid. They have no definite shape, but they do have a definite volume. Let's say if I have a cup that looks like this, and in it, let's say we have 50 milliliters of water. So this cup has a definite volume of fluid. Now, if I take that liquid and pour it into a cup with a different shape, the volume of water will not change. It will still be 50 milliliters. So thus we could say that liquids, they have a definite volume. However, the shape is different. A liquid will take the shape of its container. Now let's say if I take that liquid and pour it into a spherical or a semi-spherical container. The liquid will fit the shape of the container. And so that's why we could say that the liquid has no definite shape. If I try to do the same thing for a rock, if I take this rock and move it from one container to another, the shape of the rock is going to be the same. It's not going to change. It's going to have the same shape, same mass, same volume. So solids are rigid, but liquids are fluid. A liquid can flow. So let's say if I have a cup, I can take another cup and pour liquid into it. The gases can flow too. Let's say if you have a pipe and you have a gas in the pipe. The gas can flow through the pipe, but solids, they don't have that ability to flow. So liquids and gases are known as fluids because they can flow. Now you have different types of fluids. You have like water, which can flow nice and easily, but you have like more viscous fluids like syrup and honey. They don't flow very quickly, so they have a high viscosity. Now let's talk about density. Density is equal to the mass divided by the volume. Solids have a very high density. For example, the density of iron metal is 7,870 kilograms per cubic meter. Kilograms is a unit of mass. Cubic meters is a unit of volume. Now liquids also have a high density as well. Molten iron metal or liquid iron metal near its melting point has a density of around 6,980 kilograms per cubic meter. And for most substances, the density of a solid is usually greater than the density of a liquid. Now granted, there are some exceptions. For instance, liquid water has a higher density than solid water, which is known as ice. The density for liquid water is around 1,000 kilograms per cubic meter, which is the same as 1 gram per milliliter. And the density of water, rather ice, I should say, is 917 kilograms per cubic meter. So the density of liquid water is greater than ice. And so that's one of the rare exceptions, but generally speaking, solids usually have a higher density than liquids, and gases have a very low density. Now, just to put that in perspective, the density of air at 20 degrees Celsius, it is temperature dependent, is around 1.2 kilograms per cubic meter. And if you compare the density of liquid water, it's 1,000 kilograms per cubic meter. So the density of a liquid is much higher than the density of a gas. Now, because gases have a very low density, they are highly compressible. But because solids and liquids have a fairly higher density, they're only slightly compressible. You can't compress them as much as you could with a gas. Because a gas has a lot of empty space in between the atoms. In the case of a solid, the atoms are closely packed to each other, so there's not much space between them, which makes them highly incompressible. Now, liquids, on the other hand, the atoms and molecules in the liquid, they're still pretty close to each other, kind of like a solid because the densities, it doesn't really vary much. However, notice that they're not as neatly arranged as in a solid. And that's because they're free to move. They're fluid. In a gas, the particles are very far apart from each other. And so because of all that empty space, you can compress a gas. Now let's talk about something called phase changes. So what is a phase change? It is the process by which we can change from one state of matter into another. So let's say if we have a solid, let's use ice for example. If we add heat to ice, it's going to melt and it's going to turn into basically a puddle of water. So it turns into a liquid. Now, if we add more heat to this liquid, it's going to vaporize into a gas. And so what happens is it becomes steam. So whenever you add heat to a solid, what happens is the atoms, which are originally close together, they begin to move apart. And as you add more heat to a liquid, it turns into a gas, causing the atoms to spread even further away. Now the opposite is true. If we remove heat from a gas, it can condense back into a liquid. And if you take away heat from a liquid, like let's say if you put a cup of water in a freezer, it's going to solidify into ice. And so you can control the states of matter that a particular substance is in by either increasing or decreasing the temperature, by putting heat into it or removing heat from it. Now let's review some terms associated with phase changes. So if you have a solid and you convert it into a liquid, that process is known as melting. If you have a liquid and if you convert it into a gas, this is known as vaporization. And if you go directly from a solid to a gas, this is known as sublimation. A good example of sublimation is dry ice. Dry ice is solid CO2, carbon dioxide, and it will skip the liquid phase, thus it's called dry ice. It goes straight into the gas phase. So the processes listed above, these are known as endothermic processes because they need to absorb heat to occur. Now for the next three processes are known as exothermic processes because heat needs to be released from them in order for it to occur. So going from a liquid to a solid, this is known as freezing. Now going from a gas to a liquid, which is the opposite of vaporization, this is called condensation. And going from a gas to a solid, this is known as deposition. Now there is a fourth state of matter, which is known as plasma. This state of matter is an ionized gas. Now the way you can create a substance in a plasma state is you need to take a gas and you need to add heat to it. Once you add heat to it, it turns into a plasma state. And so this process going from gas to plasma is known as ionization. The reverse process is known as recombination. And so let's talk about that. So let's say we have a bunch of gas particles just floating in the air, and we're going to heat it up. Now, if you heat it to a very high degree, eventually some of the electrons in these atoms will be stripped off the atoms. And so basically, you're going to have ions with a positive charge. These are the atoms that lost electrons. And not too far from these ions are the electrons that were stripped away. Now here's the key difference between a gas and a plasma. A gas, in its neutral state, does not conduct electricity. A plasma, or an ionized gas, does conduct electricity. Now, plasma is present in places like the sun, where you have a very hot ionized gas. It's also present in neon signs. They use plasma to generate light. And even fire. Fire is part gas and part plasma. Another good example is lightning. So in order to strip the electrons in a gas to create plasma, you can add heat or you can add even electricity, because neon signs, they use electricity to separate the electrons from the gas particles, creating this plasma state. But now, once the ionized gas particle and the electron, when they recombine to form an atom, they will emit light and heat energy. And so that's how neon signs work. They use electricity to separate the atom from the electrons, and when these atoms, or rather when these ions and electrons recombine to form the atom, they emit light as a result. So that's my 2 cents on the 4 states of matter. That's all I got. Hopefully you enjoyed it, and whatever you do, don't forget to subscribe to this channel if you want more educational content and things like that. So thanks again for watching.